there's a particular type that can come up in verbal reasoning which involves numbers, and it requires excellent mental arithmetic skills. So in doing these questions or practicing these questions, it will really sharpen up and test your mental arithmetic skills. What you get is a set of numbers, then they're in sets of 3. And you get 2 numbers which are outside the brackets, and then you get a number inside the brackets. And you get the same with a second pair. Then you have a third pair where the number in the brackets is missing, and you have to work out what that number must be. The rules are that you can apply any mathematical operations to combine the 2 outside numbers in order to make the inner number. Now there are certain terms that I use which I find helpful for this, the left number, L, the right number, R, and then the target number, T. And I'll label all of them in the same way. So the left number, right number, target, left, right, target. So your job is to figure out how do you combine L and R to make T. So the way you combine them is called the function. So what a function is, it's one or more mathematical operations. So that could be as simple as adding left and R, or subtracting them, or multiplying them, or dividing them, any single operation. But it can also be a combination of operations. Now, example 1 naturally is a very straightforward one, and I'm sure you will have spotted what the answer here is. It so happens that 9 add 5 makes 14, and then we can test that with the second set to see if it works here as well. 32 add 7 is 39. So because the same function works here and here, we know it's the right function. If the function had worked here but not here, I would have to find a different way of combining L and R to make T. So one of the rules is that the same function exactly has to work here and here before you apply it here in order to get the answer. Now, another very useful thing for you to do is to actually write down the function, because what you're then doing is practicing algebra, which is a very useful tool for you, and it will help you with solving certain types of problems. So to practice the language of algebra, what I'm going to say is that the target is equal to the left number plus the right number. In algebra, it looks like this. T equals L plus R. Very simple formula for the target number. And in this case, L plus R is 16 add 8, which is 24. So that's about as easy as a question of this type would get. We'll take another example. So these are the sets of numbers. Your job is to figure out what the function is for the target and what the target number is in the third set. So you would try a single operation first. Now, don't randomly try operations. What I suggest is that initially look at the target numbers, compare them to the outside numbers. In example 1, the target number here is 14 as compared to 9 and 5. It's larger. Here it's 39 as compared to 32 and 7, so it's larger. So the first thing I would try is some increasing operation, which means adding or multiplying or squaring. Those would result in bigger numbers. The opposite of that would be decreasing operations, such as subtraction, division, and square rooting. So that reduces the amount of time I waste trying something that was obviously going to be wrong. So here I would have tried the increasing operation of adding first, because it wasn't massively bigger than the outside numbers, just a little bigger. If this was in the hundreds, I would have thought of multiplying first. Here, though, the case is different. Here I see that the target number is smaller than the bigger of the outside numbers. The same is true here. So I would think first of a decreasing operation. So that would be subtraction division or square rooting. And square rooting and squaring are rare, so I would only try them if I had tried other things first. So I'm looking here at subtraction. 28 take 4, that doesn't get me anywhere near my target. So I would try division. 28 divide 4 makes 7. So I would test whether that function works here. 12 divided by 6 makes 2, which is correct. So I've worked out that the function for t is L divided by R. So I can write it as L over R. That's one way to write that in algebra. And when I apply that function to the last set of numbers, I get 32 divided by 4, which is 8. Let's now look at an example which is just slightly more challenging. So supposing we had 17, 16, 15, and then 38, 22, 6, and 25, and 11. Now again, looking at my target numbers compared to my outside, I see that the target number is smaller than the larger of the numbers. Target number is smaller than the larger of the numbers. So I would tend to think subtract when I see that. I would try subtract first. 17 take away 15 is only 2. So that doesn't work here. And 38 take away 6 would have been 32, which is nowhere near where I want to be. So a single operation isn't going to work here. So this straight away I can see that I'm going to need 2 operations. This is where some trial and error comes into it now. 16, I notice, is exactly halfway between 17 and 15. And 22 is exactly halfway between 38 and 6. So I now know which operation or which function I have to use. If I add together 17 and 15, that makes 32. And then to get my 16, I halve the total. I'll check that works here. 38 add 6 is 44. Half of 44 is 22. So I've worked it out. So it's left plus right, then divided by 2. And I would write that in algebra as t is equal to left plus right divided by 2, which we would normally write as a fraction. And when I apply that to the third set, it's 25 add 11, which is 36, and half of 36, which is 18. So you can see that because it can be any combination of operations making the function, it is such an excellent test of your mental arithmetic and such a good way to sharpen up your mental arithmetic skills. That could have been any combination of operations, and the more practice you do, the better you get at looking at the numbers and knowing what is going to be a waste of time and what might result in some progress. Let's take another one. Okay, let's first look at the target number. And I noticed that the target number is less than the larger of the 2 numbers. So the first thing I would try here is subtract to see what happens when I do L minus R or R minus L. Here, 45 take away 19 would give me 26. Now 26 is not very far from 28. I could just add 2. So I would test that function here. 105 take away 76 is 29. And if I add 2, I do get my target number. So I've just solved it. The function is left minus right, then add 2. And in algebra, I'd write it like this. T equals left minus right, add 2. Now, just to make it extra clear for yourself, you could put brackets here, though it's not necessary, because according to BIDMAS, you should do the add and subtract in the order they're written anyway. But I've put the brackets there just so that it's not possible to do them in the wrong order. Right, let's take yet another example. As soon as I see a decimal point in the target number, when there is no decimal point in left and right, I think divide by 10, because that will give you a decimal. So that's the first thing I would do. So how do I make 7.1 out of 31 and 4? Well, straight away I can see that there's a 0.1 here, and there's a 31 here, there's a 0.6 here, and there's a 56 here. So if I were to divide the left number by 10 here, I'd get 31 divided by 10 is 3.1. And then if I add the right number, I get my 7.1. Try the same thing here. 56 divided by 10 is 5.6. Add that to the 15 and we get the 20.6. So it's actually quite straightforward once you've come across one question like it. So the function would be written as left number divided by 10, add the right number. So t equals L over 10, add R. When I apply that here, I get 12 divided by 10, which is 1.2. Add that on to 23, and I get 24.2. So we're getting slightly complicated now. And remember, there's no way to practice every set of operations. The whole point is to figure out which set of operations or which function applies to those particular numbers, which there's no shortcut except to have excellent mental arithmetic. This one is a step up again in difficulty, and you would not get many questions as difficult as this. But I'm throwing in a couple of examples just to show you how potentially difficult or awkward they can be. Most questions of this type would contain either a single operation, like examples 1 and 2, or they would contain two operations, like examples 3 and 4. And indeed 5. But in example 6, I've made it more complicated simply by having 3 operations making up my function. And you would know when to use that because you try various other combinations and not succeed. So for example, my strategy would be first to notice that the number is quite a lot larger than the outside numbers, and again quite a lot larger than the outside numbers. I would tend to add them first, 6 and 7, 13, 13 up to 30, double it and add 4. That works here. So add them together, 19, double it is 38, add 4 is 42. So I've worked that out quite quickly, but sometimes you'll try many things and it won't work out. However, the function written using algebra looks like this. We added the left and the right first, L plus R. Then I doubled the total, so I put that in brackets and double it. Then I added a 4. So there are 3 steps here. L plus R is one operation. Double the total is a second operation. Then add on a 4 is a third operation. Now they wouldn't get any more difficult than that because it's way too difficult then to do in a test. And even questions involving 3 operations would be rare. So the vast majority will involve either a single operation or 2 operations. When we apply this function to this third set here, L plus R is 23, double 23, 46, and then add the 4 makes 50. Have a think about this one. It does involve 3 steps. The extra thing which I've introduced into here, which is rare, but just to show you how it could work, is this. The left number in each case, I notice, is a square number. That is rarely a coincidence. It's something that, with some experience, you may also notice. Those are all square numbers. And when I see square numbers, it's a clue that maybe it involves square roots. So I would try that. The square root of 9 is 3. And if I do 3 times 11, that gets me to 33. And then I would subtract 9. So I don't know if that's right, but it does work here. And the reason I'm trying square root is because I observed that the left numbers are all square numbers. So square root of 9 is 3. 3 times 11 is 33. 33 add 9 makes 42. So that's 3 operations. Let me repeat those 3 operations to see if it does work here. Square root of 36 is 6. 6 times 20 is 120. And 120 add 9 would be 129. So it worked here, but not here, which means that I haven't got the right function. And this is normal, that when you try it, especially a complicated one, it would take you some wrong attempts before you find the right one. So it's back to the drawing board. So I'm going to try a different approach now, because what worked here was way out for here. So let me try something else. Square root of 9 is 3. 3 add 11 makes 14. And to get from 14 to 42, multiply by 3. If I repeat that function here, I need to square root the left, so that's square root of 36, which is 6. Add the 6 onto 20, which is 26, and then triple 26, which makes 78. So that is the correct function, which I will write like this. So we take the left number and square root it. Then we add to it the right number, and whatever the total is, I multiply it by 3. So square root the left, then add the right, and then whatever the total is, triple it. And when I apply that here, the square root of 4 is 2, add it to 50 to make 52, and then triple 52 to make 156.